Hello.
Sai, your voice is echoing.
Yeah, that's what. I think the system sound is off, but still it is echoing for me. Is it still there?
Yes, yes, it is.
Hello? Yes?
Sir, now it is clear, sir.
Is it clear now?
Sir, clear.
Okay, okay, okay. So a warm welcome to everyone. Um, so I'll be taking care of this particular topic, which is artificial intelligence, and we'll go through certain topics that covers under artificial intelligence, and I'll take some practical sessions over a particular machine learning algorithm, so that you will get some clear picture on how it is get implemented, and also some examples related to the advanced machine learning concepts. So we'll start now. So I think my audio is clear. If there is any discrepancies in between, you can pass me in between and inform. So yeah, we shall start. So here, I mean, everyone have a great idea over the artificial intelligence, and so here I start with an understanding that AI is something. It's not something away from us. It is within, everywhere. It is everywhere, and we from start today, from the day-to-day activities, we have started utilizing AI, maybe knowingly or unknowingly. And when we start to explore these things, the AI concepts, there are two major things that we need to keep in mind. That one is like uh, this AI, any applications that belongs to AI is only for the development purpose of the humankind, and we also provide a solution, and like finding the different problems which cannot be solved immediately, or at a cost of huge cost. So we'll define those problems under AI and try to bring what is the possible solution. And so from there, it started with a very long journey. The concepts that we see within the artificial intelligence and whatever we're going to see today, everything has been started very earlier, and which is just within this 10 years of time, it get boomed, and we are talking about AI, machine learning, and other concepts. So to enter into the major topic, here we have three names, which is like AI and machine learning and deep learning. And from this image itself, we can understand that each of the topics that we see here is a subset of one another. So if you take artificial intelligence, it covers the overall uh, the conceptual ideas behind this machine learning and deep learning. And if we say machine learning, from the as the name suggests, we develop many of the researchers have developed certain algorithms which can train or learn from the existing data. The here the major concept is we'll have some the historical data. Everywhere it is data is a very important thing, and we as all know. And so like time by at time gets increased, we'll get more number of data, and with that data we're going to process them, and we're going to make the algorithms to learn them. Learning is nothing but make a analysis, and providing a particular collecting relevant information. So these are at layman terms we can explain it very easily, but in deep within this machine learning or the deep learning concepts, it is big. And so that is what the machine learning does. And if we say deep learning, it is another subset of machine learning where it is a separate topic, considering a neural network, which is a very specified algorithm found in machine learning. Before the neural networks, there were multiple different fuzzy logics and the other implementations or algorithms, and later on it gets boomed into a different platform. So the deep learning got a special attention, and so this is what the artificial intelligence covers for. And so yeah, so this is a major differences, but if we see, like as I said, like it is from the learning of the data. And so I'll mention the data as historical data, because like everywhere the previous data will be used, so that the new data, whenever we provide, the algorithm can process them and try to bring out the solution. So as a overall, I'm just like describing everything in a very general term, but in a specific application wise, it gets differs. So that's what we're going to see in the upcoming sessions. And so there are major three types actually in the when it comes to machine learning. So one is supervised, and another one is unsupervised, and the last third one is we have a different kind of a method, which will which will be like apart from all these two types that you're going to see. And if we take supervised learning, it will have its own the data defined, or we'll provide the algorithms already defined data to them. So whenever we say algorithm, like it starts with a very basic level, and also it gets advanced level of implementation. And in supervised learning, you will have your according to the problem, it will have its own defined set of labels. So whenever we say label, that we're going to provide the algorithm that this is a particular data that belongs to some particular classes or label, and so that it will know that this particular data will be grouped together into a particular class or label. And so this is what happened in supervised learning. We provide the existing uh, like the existing the backbone of all those data and its information to the model or the algorithm itself, so that it can learn from that. And if we take unsupervised learning, we won't provide any particular kind of labeling, or we won't say that this particular group of data belongs to this particular category. But the algorithm itself can understand from the data that has been grouped together, and try to predict the particular data which belongs to which category. And so here, like basically, we'll have two major kind of application that we develop for. One is like the classification problems, and another one is regression problems. So in both of them, like the supervised and unsupervised learning will have its own the implementation. And so here in supervised learning, there are certain examples, like price of a house, whether person click the ad or discrete set of response. So here, as I said, like in supervised learning, we'll provide the existing analyzed classes or the categories to the input algorithm. To the algorithm's input, so that it can easily identify and learn based on that. So if we take unsupervised learning, it is something different that algorithms itself take a particular extract the features from the data provided, and they try to analyze or categorize them or predict the particular data that we're going to provide as a solution. And as I said, like there are two major models, or we say the problems that they provide solution for. One is like the regression, and another one is classification. So in regression, it is like there are a group of data will be there, and we try to provide the next response or the next set of data to be predicted at based on the before data. Like in classification, it is like we're going to we're going to same, the prediction will happen here also based on the future data. We're going to predict the for the input data that we provide. But here there is a specific focus that it's going to class or divide the particular data or group of particular data into a particular category. And so there we consider um, most of the problems that we deal here will be classification problems, and also like in terms of like the data solution that we're going to provide, the regression model will be chosen. So it is absolutely based on the application that we're going to work. So that's what this particular machine learning application uses. And so if we take what is the backbone, or what is the structure of the implementation done in any machine learning model, will be what you're seeing now. Um, so here, like as a overall overview, I have said that we'll provide the historical data, and it's going to learn, and we're going to like provide a new data similar to that of what we have provided as an input, and try to find the output. So here there are two things that we need to keep in mind. One is the set of inputs that we have, and the set of outputs that we have. We need to have a clear understanding that what is the input that we're going to provide for the solution, and what will be the exact output that we need. So with this definition, we can start with a basic analysis over the data. So just to provide a gist of like the machine learning understanding. Before any machine learning application that any implementation that we're going to see now, before that we have a separate step or implementation that we need to do, which is exploratory data analysis. So because here in machine learning, we can give n number of inputs. That's not a problem, and it's going to learn from that. But we need to make the model or algorithm to understand how it's going to use that particular data to predict a output data. For example, like there we took an example like price of a house, and that is a very basic example that we try to explain. Based on various like the data, if we collect for a particular prediction of a price of a house, we need to have a certain input data, something like the area where it is located, or the number of houses, or the number of amenities found near to that particular area, something like that. Like the relevant data needed to be provided as an input to the machine learning. And so like as I'm saying, like in a developer point of view, we will be provided like some n number of data. Say for example, like we'll be provided with 10 number of inputs, which will be as a in an overview we can say that it is everything is relevant. But when it comes to analysis of that particular data, some data will not be required, because it won't have any effect over the output that we're going to predict, or we're going to provide the solution. So we need to eliminate, and we need to process the input data according to the algorithm's input. So these all these things will cover under a specific topic called exploratory data analysis. So there we'll have a number of procedures like data cleaning, data processing, um, uh, Like we need to label the classes for the supervised learning, and even for unsupervised learning, we'll have the idea that which data will be grouped together. So which will comes under which category we'll know, but still we need to make that arrangement of those particular data when we go going to provide the input to the machine learning model. So I'll say that uh, even though the machine learning is a very machine learning or deep learning algorithms are the backbone to the problem that we're going to face, but the like if we put our 60% of work over the data pre-processing or the data exploratory data analysis, it will be better for the machine learning model to to provide a better prediction over the input data. So now we'll get into how the machine learning model works. So initially, as I said, like there are two things. One is data acquisition and data pre-processing. Here, when it comes to data acquisition, there are major factors that covers under acquisition. One is we need a set of input data or large number of input data to be provided to the machine learning model or deep learning model. So here the data acquisition will be like we can say 2 points. Like one is you can have the exact source of data that you're going to work so that you can get from that source, or you need to create your own data set for your own application. So these two things, one is the collection of existing data or the data set, or we need to create our own based on our application or based on our problem statement. So these two things comes under data acquisition, and the process of many technically speaking, like the acquisition will be from in a different point of view. Like we will be provided from the like the from any kind of a website, or we need to take the input data from a particular mission, or like if you are going to take an data from the industry, it is like maybe it could be some of them could be a live data and some of them could be historical data. So the all these things, like how we are going to acquire those particular data, will be comes under this data acquisition. And the next step will be data pre-processing, which I have already told you. There are many steps that are involved in data pre-processing, like cleansing the data, transforming the data according to the machine learning model, and so all these things will be taken care in data pre-processing. And once we acquire the major input data that we're going to that we have after analysis, whatever we have chosen, it will be as a like we need to have them as a one particular input data set to the machine learning model, and then we'll have a basic step that we need to carry on, which is like splitting those data set into two or three major things. So when it comes to two major things, it is like the training and the testing data. So like another one that we can add is validation. So I'll explain what these three major things what they are. Like the training data is nothing but same input data that we take in terms of like 70% of the overall data set or 60% of overall data set comes under this training data. So initially these data will be taken as an input to the machine learning model, and it tries to learn from that. Like the algorithm will calculate, or the mathematical operation behind that will extract those features or the meaningful data that can be collected from that processed from that particular input data, and that will be kept under that particular algorithm. So the output will be different for the different machine learning models. And then we have test data, which is again the same input data that the remaining 30% or the 40% from the original data will be given to test data. So what we do, whatever we have trained in the original data and the model that it has learned, it will we will be testing there after that particular training has been done. And this is to ensure that how much it have performed in the training and how much it have performed in the testing, and we'll have some comparison over the training and testing, and we'll try to provide whether this model can be a better one or not, or this particular machine learning model suits our application or not. So these understanding can be brought over this training and testing. But in terms of a real-time application, we does this very long before, like while the data pre-processing itself, we'll choose which machine learning model that can be a better one, which can perform in a good way, both training and testing. So based on the experience, like we need to choose the exact machine learning model there itself, so that the time can be reduced. So this is what the major like the work or the structure of the machine learning model. Then after training testing, like anyway, like if we say that it has been trained, then we're going to take that model, we're going to provide the input, and we're going to get the output, which will be a predicted output. So whenever I say prediction, so it is there are major other concepts that I'll get into. So the prediction of for the new data, like those new data will not, this model will not have never seen, maybe a similar kind of data that it could have seen in the training and testing, but not the exact combinations of those data. So for that it will predict and try to say that this particular value or the particular output. So that's what we do in this particular machine learning model. So I think I have explained all these steps. So this is the overall flow. And here, this step, as I have said, like from the point of view that whether it has performed good in training or testing, or whether poor performance, all these analysis. After that, again, the data should be evaluated, or the input data that we're going to provide, and also the model that we have chosen should be evaluated carefully, so that it won't get any kind of like it won't have. I mean, it doesn't have any misconception between the input data and the model that you're going to use. And then the final stage is to deploy the model, in terms of you're going to use it in an application, or you're going to have it as a separate module. So that depends on the application over. So here, when it comes to the machine learning, the major implementation over Python will be done using this particular library, which is scikit-learn. So this particular library, we're going to take all the necessary functions and the necessary algorithms that we're going to use. Everything will be found within this particular library, and we just want to utilize certain the functions provided within this particular library, and you can utilize that, and you can make this complete machine learning algorithm to work on our data. So here it is provided with the syntax, like for installing the scikit-learn, and this is very general for any kind of a Python library that you install. And so here in scikit-learn, like there are basic steps that you need to carry out. So this is again the process carried out in the machine learning model, that I mean the machine learning structure that we have seen before. So like it programmatically, like we need to have the data frame, which is said to be the input data that we have acquired, and the data pre-processing will happen. For those, like we have within Python itself, we have pandas for handling the data. We have NumPy for any kind of mathematical calculation. NumPy will be used, and for other visualization libraries like Matplotlib, Seaborn, or Plotly, we have some the major Python libraries that will be helpful for both data acquisition and pre-processing. Then we'll say, like from the scikit-learn, we'll have this test train split. So from there, like we divide the data set as we have seen before. And so here, we'll have four major variables that we get to provide as an input to the machine learning model, which is like x train, x test, and y test and y train. So the x and y represents the input and the output, and so x will have group of independent variables, And so here the train and test will be the percentage of data that is split. And so after that, like from the scikit-learn library, you will have all your machine learning models as I told, like it will be in terms of a function. So all those functions will be defined in the back end of this particular library. So you can import all those machine learning model, whichever you're going to use, and you can create this x train and y train data. So for the input x train, what is the output, which will be the weight rank. So we'll already have this input and output. So we're going to provide to the ML model. So and at final, like again, it will get us a particular Y predicted, which will be compared with Y train. And when we provide the X test data, we're going to compare it with Y test data, which will be Y predicted. So this is the basic understanding of this how this we're going to utilize the scikit-learn library for the machine learning application. So but like in the practical session, I'll show you what is that, how is that step has been covered. And so here you have a like we have added certain slides to make understand about the regression model using a particular algorithm. So here in this picture you can see there are two particular data have been plotted over, which is x and y. So X will have a particular input data and single input data, and Y have an output data. So correspondingly, for every X value, you have a corresponding Y value, and to bring the like an understanding over how this X and Y is being in a how it is related, we just plotted a graph and we just draw a line which is said to be a 2D regression line. And so this is a basic understanding that whenever we have a like a line drawn over two variables or two items, always will have the straight line equation can be a greater solution to understand how the data for those both two variables have been defined or deviated. So these things can be analyzed. So we are going to particularly we're going to use this regression line which is drawn over the formula which is provided there, like y equal to mx plus c, which is a straight line formula. And we can extract three things from there, like so one is like how this x data gets deviated or related to that y using their coefficients, and and also like how this both data is being like I would say like how it is positively increased or positively decreased, or negatively increased or negatively decreased, which is like how does x affects y. So these kind of relationship can be analyzed over like in the before stage itself. But to make this model, machine learning model, to understand for this particular regression model, we're going to utilize this particular formula. And so whenever we talk about like a single independent input and the dependent output, we can have that particular formula. Like that's a basic formula, and it has more value to it. And if n number of input data has been provided, then the coefficients and also the degree of uh, um, the formula or the line that we have already used for a particular x, or the input value and the output value will get extended. Like it will get extended in terms of degrees. So like here you have two inputs that going to affect y. So the possibility will be like if x increases and x1 increases and x2 increases, y can also increase or decrease based on the relationship. If x1 decrease and x2 increase, y can have the output like increased or decreased. So these kind of possible combinations are there. So if we have 10 number of data, we can itself do it. We don't need any kind of equation. If you give me like 10 rows of data, and if you provide me two inputs and one output, I can itself say that the relationship between this x1 and x2 over y. Even if you provide me 100 data, I can utilize some idea of visualization or two. If you have lakhs and lakhs of data, then this where this machine learning model gets help us over these algorithms. So here you can see a 3D plane over the data that has been plotted or visualized. So this is how the regression gets increased whenever the data input data is get increased. So here everywhere this equation is same and the concept behind this straight line will be the same. And so the basic regression that I mean any machine learning model will start or will be like a linear regression, which we have seen as an example before. So in kind the linear regression, like we'll utilize the equation of line, and we just going to as I have already said, like the relationship between x and y and how it affects the predicted or the output data that we have as a y. So here we have a example of a case study, and which I have said like house price prediction. So here you just consider there are five set of parameters which we order it from x1 to x5. So you have average income, age of the house, number of rooms, number of bedrooms, area, population. So all these factors are the inputs to the machine learning model for this particular solution. I mean, this problem statement to predict the house price. And as we have already seen, like as number of data increases, this particular equation also gets changed. And you can see all those coefficients which is going to define for a particular input over the output. And the output here is the price, which is defined as y. And so when we start with the any regression model, so from the x and y relationship that it's going to have, like the positive and negative influences or the correlation, everything will be will be adjust over that particular coefficient over the input data that we provide. And this is what this regression model will takes care of. And there are some error findings or as we are comparing from the x and y, we'll always have how much deviation that particular input value that it has over the output. And this we does this for overall the predicted and the original data and the predicted data. So that also we're going to apply the same. And so there are the error can be found uh, from the this particular formula that has been going to be defined here. And so there are three major things. One is like the absolute error. Like the whenever we say absolute error, it is simple that from the original data, how much the new data or the data that you have in your hand gets deviated. That is absolute error. That it is very common. And this mean absolute error is nothing but for the number of instances that you have, you're going to find the differences, and you're going to sum them over the number of iterations that it, number of instances or the iteration that it has. So that's what this mean absolute error will take care of. And so why we use this particular errors are nothing but kind of I would say like evaluation or like you will have your training and test data. As I said, like at the end we're going to evaluate over the predicted output. So this is how it is done in this regression kind of models. We take this mean absolute error, then we'll have uh, mean squared error. Here it is. So this is squared error is nothing but like you will have n number of data over, and the comparison between the input and the output, which will be like the differences will be more. And at that point of time, this mean squared error will also have its own effect, which will be like the difference between the actual and the predicted will be squared, and then it will be taken into the mean of all those data will be taken care. So this mean squared error will have there will be a basic comparison over this MAE and MSE. So this MSc, like therein, if you take MAE, the differences are absolute. That's what it defines. It is just the differences, and sometimes like if there are more deviations happen, then we cannot exactly bring those. Understand the how much it has deviated. If it has more number of deviations, if it is less, then MAE absolute error, mean absolute error is enough. So this mean squared error will reduce that because of we are taking the square of those particular errors that we get. So we can take care of that particular deviation, more number of deviation that it takes place in the prediction and the actual. So that is one error, and the another one is the root mean square error. So this RMSC will be majorly influencing evaluation parameter that we can create for, use for this regression model. And so here in this RMSC, whatever we see in the MSC value, we're going to take the square root of that. And by performing this, again, you're going to reduce for the maximum number of deviation, and you have a particular scale of values, like I would say, like from 1 to 10. You're going to say how much it has been reduced, how the deviation has been reduced. If the actual is 50 and the predicted value is 55, it's not a bigger issue comparatively. But for 50, if it says 100, then the deviation is more. And if this is happens for n number of data, like I would say like 10,000 data, then see how we can analyze how much it has affected, deviated. It will be more in a large scale. The values will be more. So these errors will reduce that or quantify these deviations.
ఇది కాదమ్మా ఇది insects have dash legs six కదా sir what is the appropriate value of this root mean square error sir 0 point something or anything like that what is permissible error
We'll be having it in terms of scale of 1 to 10, and also 0 to 1 also be considered, like the based on the other regression models that we use.
okay sir
Oh, sorry, it is getting out of control. Just a minute. Yeah. Um, Actually, here I just covered this topic also. This is whatever you have seen in the before thing is the linear regression, in which like we use that particular line that is going to adjust for the x and y data that we consider. And here in this the logistic regression, it is something different, that a particular the straight line over the comparison of the deviation of that x and y will be here done in a curvilinear fashion. So that's what this logistic regression will take care of. So like why we chose this particular curvilinear kind of regression is to provide a basic understanding of the difference over the input and the output data. So as I've already said, like we're going to compare the x and y over how it is positively like correlated, whether it is increasing or decreasing, or negatively it is increasing or decreasing. So these understanding can be brought into a larger picture, or can be easily understandable over the large number of data that we choose. And so here, if you take this particular example, for any like the input value that you provide, the corresponding y value will have a particular threshold in which if it reaches above that particular threshold, how it is going to behave, and below that threshold value, how it is going to behave. That is the which cannot be brought in the linear regression. So this is one of the other regression type that you see. And apart from this linear and logistic regression, like you have different regression algorithms like ridge regression, lasso regression. There are other algorithms which have the same kind of a pattern over this regression techniques like linear regression or logistic regression. But in quantifying the error, or in some of the other algorithms, like while training itself, the error will be reduced there and there, then and there. So the error calculation will not happen at the end, will be happen while for each iteration in the overall data set. So this is another kind of method that it uses. So if you take this classification model, here the classification model is, as I have already said, it can be easily understandable that we are going to provide the input data. We're going to predict, but we're going to predict which classes or which category that it belongs to. And so that's what this classification model will help us. And if you take like here like the directly I have come to the evaluation part, because the steps that we're going to carry out in regression or classification is everything the same. And if you see here, there these are three or four major things that we're going to take it as a evaluation metrics. There we have seen the root mean square error and all those things, because that is the exact value that we have predicted for the current value, and we can find the deviation. Here to provide the classification, so here we derive this accuracy, recall, precision, and FN score. So like the precision and recall is nothing but the number of correctly identified classes divided by the number of the correctly identified or the predicted. Like I would say, like the correct in the sense like the original data or the ground truth data, and we provide uh, the exact class that it has predicted. So from these two things, we can calculate this precision and recall. So you have true positive, true negative, and false positive and false negative. So this for any kind of a classification model, this will be a basic um, parameters that it finds. And for any kind of a prediction of that particular classes will comes under this. And also the deviation here will be of uh, maybe it could have correctly identified that particular data, but the classes it could not have identified correctly or classified correctly. Sometimes the data will be um, uh, the exact data will not be provided or predicted, but it has correctly identified the class. These kind of problems can be defined within this the possibilities form that you can see here. And these particular formula that have will be derived from the true positives, which is like the correctly identified or the correct ground truth classifications or the classes. So this is what the evaluation metrics. So the precision, recall, and accuracy, all these will be in terms of percentage, or we can say it in terms of 0 to 1. So like we'll generally like the precision recall, we'll say like both of them having more than 0.75 is a good, or the a good model or classification has been done in a positive way. So that's how we'll say. And F1 score is nothing but from the precision recall, we'll be calculating a specified number of a score, which will again comes under 0 to 1. So that I'll be saying like the precision recall is enough to understand how it has correctly identified that particular data and classify them, and how poorly it has identified and classified them. So these are four major things that we need to take care of in classification model. And here are some machine learning models which I can name. Here you have the KNN, which is K nearest neighbor. So this is, as I have already said, like we'll be provided the input data, and we have already, we will be classify them to a particular class. And here you could have, I mean, you can see like there are some group of data that belongs to red class, and green and blue. And from this particular graph, with this algorithm, like the KNN will choose a particular value which is set to be the K, and it will try to, from that particular data, it try to identify how much nearby data is similar to that of the original data. As an example, like if you take this uh, particular the house price prediction itself, there we had like the area of population or number of the age of the house, something like that. And you have n number of other data too, like other group of relative data that you have. And you can compare one data with another, like not to directly to the output. I'm saying only within this input data. That is the normal comparison that we do, like how this age of the house affects the area of population, or uh, uh, those kind of relevant data, how it is being compared. So that can be found within this, or grouped together, of those relevant data will be grouped together using this KNN. And here, if you take a particular point, and you need to choose number of members that is going to take, or for example, let you say like five. So the nearby five members will be taken, and its data will be analyzed, like how it is relevant to, or how it is similar to that of the data chosen. And so this will be happening over all this group, and finding those particular the data around that particular number of value that you have chosen, from the distance that it has. Distance is nothing but the equation that we calculate for a 2 point within a particular plot. Like there are multiple equations, um, like a 2 point distance calculation. So from there, like it will be like calculating which is the least distance from that particular point that you have chosen for a particular classified object, I mean classified data. So from there, like all those least distance points will be taken care and grouped together. And this grouping also done in terms of consider this as a predicted data, not as an input one. Consider that as an output data. So for that, the particular relevant data will be grouped for the number of the data that you choose. So that's what happens in KNN. Like the grouping of data or learning them will be taken care by number of data that you provide as an input, and from there, like the distance will be calculated using various formula, and that's what the KNN does. And here you have other machine learning models like support vector machine. So this will take like you have a particular group. Consider this as an example. You have two classes here, class one and class two, and you need to have a plain kind of, you have already seen a kind of a regression line that drawn in over the x and y, but there we don't have to consider how much I mean what category that it will belong to. We need to only take care of how it has deviated. But here, if you see, there are two classes, and there are some mixture of other data in both of the classes, which should be belong to that particular class. And if we need to divide this exactly to provide a model to understand how it can be classes can be divided, we need to provide a particular planar equation, or it will be adjusted to a particular data. That's what you're seeing here, according to how the data has been distributed. So here the distribution is nothing but for the input data that you have, these classes will be plotted, and by visualizing that itself, like we can understand from which group of data belongs to which class, and why it is why this deviation happens over this particular classes for the input data. So there will be a planar equation that covers most of the data that is grouped together, and those one or two deviations will be considered as error. So this is what this support vector machine uses, and this also again have its own like the planar equation will be created starting from the 3D equation to consider multiple points, and all those edges or those points will be considered for that particular equation. So everything brought together, all those data will be brought together, and you guys you need to visualize over these kind of plots. When it comes to the calculation, it can have it over the number of instances that we provide. But for our understanding, we need to have this kind of plots to make us clear. And this is another kind of a problem that we deal, which is clustering. So the clustering it will be like we don't provide any kind of classes in before algorithms that you see. While training itself, we provide this particular data belongs to this particular class. But in clustering, we won't provide, but it extract the features from that. The features are nothing but the relevant and important data that belongs to one particular set of data that you consider. For example, you have 100 input data. You just split them in terms of 60 and like 50, and then another one is 25 and 25. If you take this like this group, all these 50 will not have the same kind of a pattern of input data that we have, like x1, x2, x3. But from the other 25 percentage or another 25 group, it can take the relevant data and try to group them together. So this is what clustering does. And so from the in the training data itself, the relationship between those x1, x2, and x3 with relatable to the output will be grouped together, so that we can easily say that the clustering can easily find out which group of data comes under which like, which data comes under which group. And so here also the how we have chosen in KNN, which is the nearest neighbor. There we choose a particular value to separate them, or to find the maximum distance around a particular data. Here we also provide a particular value which is said to be cluster. So it will create you that number of clusters or groups, so that you can find the grouped data together. This is will be much useful whenever you don't understand about a particular data, but you need to group them according to a particular relationship that is found within that input data. So that's where this clustering will be helpful. And whatever algorithms that we have seen, this can be applicable over the both the data which can be used for any kind of the real-time data that we have. Also, it can be applied over visual data, which is like the images or videos. So there also it can be applicable. So here we consider only the data simply. There we'll have the pixels for any images. So that's what. So all these algorithms or whatever we have seen, it has these kind of a pattern over every machine learning application. Only two things going to change. One is the how the algorithm calculates that, and what is the evaluation metrics that you choose for any the problem that you work on. So for classification and regression, we have seen all those error metrics. And now I'll just go through the particular implementation that has been done, so that like whatever we have seen now, uh, we can see in this particular implementation. Hello, am I audible, you guys?
Yes, sir, you're audible.
Okay. So I just like go through all these implementation. Um,
Okay, sure.
I think there is a small network error that I couldn't control.
Give me a second, I'll check.
Okay. Hello. Sorry for the interruption. It says, am I audible?
Yes, sir, you're audible now. So here, because of network issues, you couldn't control the system. Yes, sir, you can continue.
Okay. Um, Like there, I was about to explain um, the
Excuse me,
specific
sir.
example. Yes.
Gentle reminder, sir, you have another 15 minutes for the session, sir.
Okay. Okay.
Okay, sir. Thank you.
There, like I just tried to explain over a particular data set, which is a water consumption data set that we have created for utilizing a particular census data. So as I am from that particular background, so I want to provide the data set that we have generated, and from there, like we try to um, uh, predict how much water has been consumed over. Um, so let me try to run that. If the control is good, please go right. Start from the first cell. So as I said, the for any kind of pre-processing work or the visualization, we have libraries such as like NumPy, Pandas, and Matplotlib, Seaborn. So all those comes under the pre-processing and visualization libraries. So that's how we import. And I hope like everyone here have some idea over how Python works. Uh, but this is also a simpler implementation, and this can be easily understandable. So I have imported everything, and so now we have a CSV file. So in this particular CSV, as I've already said, like there has been some data that has been collected, and you can see the three major categories. One is, I mean, inputs. One is the number of person, and the temperature, and the humidity. With these three parameters, we try to understand how much water has been consumed, and this is the existing or the historical data that I would say. It's not based on the time, but it is a collection of data for different usage of the temperature and the humidity and the number of person within a particular room or a home that we can consider. And here, like the water consumption that we'll see in general, like we can easily understand that these particular factors will influence the water that has been consumed, and we can also have n number of other data too, like relevant data, but it is again it is based on the data that you have. Here we have only three data, which is majorly going to influence the water consumption. And so to understand how it has been influenced or distributed, we can have take the help from this particular plots. So here the plot that you seeing here is the for the water consumption data, how it is being distributed. So from here I can understand that majorly the huge number of data is found between 250 or above 252 up to 420, something like that. So the major distributions are found over here, and all the peaks that you see is the maximum distribution that this particular water consumption has, and particular for that particular data. And the next plots define the how data has been distributed for the temperature and humidity that you see here. This is for temperature, and you can see the maximum found here is the around 30, and the minimum is like from 25 to 35. So this is the minimum and maximum, and the most of the data has been distributed within 30. And the other plots that you see down is like comparison over one-to-one input and the output. So here now you can see the according to the number of person and the water consumption. So you can see like for when the number of person is um, gets increased, like the water consumption data that has been plotted over here. So to the X is number of person, and the Y you have water consumption. And for that, like you can see when the number of person is 3 and 2 and 4, you can see large number of distribution over for that particular range of values that considered within this water consumption. And so this is how we start to analyze. This is very basic understanding of how the data is, but there will be a lot and lot of steps that we need to take carry out in the data pre-processing. And now I'll get into the this is a overall plot of comparing every input and the output and their distribution and one-to-one like distribution over like the bivariate distribution. So after this, like we're going to take this as a particular data set. Um, so we have already read this CSV file as a pandas data frame, which is a particular data type that we use in Python to work with these machine learning model. So we set these input data. So we have X and Y. Like we have this X data for the number of percent temperature and humidity, and Y data will be the water consumption. So we're going to take that variable separately, go down and run those X and Y. Here you can see the X and Y that has been splitted initially. The input and output has been splitted. The next step is to split the training and testing data. So so here you can see, like as I said, like the four variables will be pointed, which is X train, X test, and Y test, Y train, and Y test. So that has been brought by this function train test split. So I have chosen test sizes 0.30, which refers that 30% of will be find in test and 70% will be in the training data. So here you can see an implementation for the linear regression. So that has been imported using this particular syntax. And so we need to create an instance for that linear regression so that that functions calculations will be brought into a single instance or a object. So there you can see lin equal to linear regression. That is the linear regression object that you're going to work on. And the next step is like to import that particular training data to its input model. So to do that, you have this function called fit. So lin.fit of xtrain and ytrain, we will take the xtrain value and provide the ytrain in at the output side. So yeah, so in the whatever comes into the chat box, I'll explain it once again. I mean at the end. Um, so here, as I said, like in linear regression, you have seen that particular formula for multiple inputs. Like you will have y equal to x1, a1, x2, a2. So those coefficients and the particular the intercept is based on the overall input data that you have, which will be compared over the output data. So all those can be extracted for the provided data, the x train and y train. So all these will be calculated and just go down, run all these things. So here, what I'm trying to do is like I have took those coefficients and also that intercepts at separately for how the coefficients are defined for number of percent temperature and humidity. That's what you can see here in that the 83 is for number of percent. So most dependent variable is number of percent, and temperature has somewhat a positive implementation. I mean correlation over the water consumption. Humidity has a negative coefficient. So after this, like we're going to predict, we can predict using this X test input data. We're going to get the X predicted. So we're going to compare for the original data that we have and the test data. So this plot that you're seeing here is the original data and the predicted data. And And the next one, I think this is the same plot. So in the above plot that you can see, for the current input value that you provide, what is the output, exact output, and the y test is the existing data that we have, and y predicted. So those two have been plotted, and so here the evaluation will be taken care, which will be like for using this function mean absolute error, mean squared error, and the RMSE. So you can see here all these values. If you take like the MAE, it is 8.55, then MSE and RMSE. So as I said, like the RMSE depends upon the application that it varies. So if here the error that it has been found is up to the range of 10. So we can consider like 0 to 10. And so then we'll have, for the predicted data, we can extract all those coefficients and the intercept value, so that we can again apply to that particular equation to exactly find out for new data. New data in the sense, if you provide one single instance of number of person, if there are three number of person and the temperature recorded is some 25 degrees Celsius, or the humidity recorded over some value. So if we provide the input to that, we can calculate what can be the exact water consumed using these coefficients and the intercept. So that is the prediction has been done over that test data. You can also from the coefficient intercept for this particular linear regression model alone, I'm saying, you can utilize, and you can find out how much water has been consumed. So this is one simple example of how the linear regression does the action of prediction over the input data that we provide. So here, the example we have seen very less number of input data, and the number of iterations or the instances that we found is very less. But in real-time application, we'll have more number of data. As I said, like lakhs and lakhs of data will be there, and we need to process them. And in terms of any kind of a regression model or the classification model that we choose, these similar steps will be taken care. So this is what happen in this machine learning application. As like we go through every different models, we can understand how for different data how this model can be suitable. So yeah, so so this is the understanding of the machine learning and the implementation. So if you have any doubts, you can post it here.
Sir, initially I've done some pairwise plot now, sir. Just show how to do that.
Okay, that part is like, as I said, like it comes under the exploratory data analysis. So you are asking like how these plots have been done.
Ah, yes, sir. Just yeah.
We use the libraries like matplotlib or cbon. So we take those input data in terms of pandas data type, and we use the different functions. Like for distribution, you have a dist plot function in the cbon library. So all these comes under the function that we use. So if you see like sns dot diskplot, sns is the library, and from that object you're going to use the function diskplot, and you're going to provide the input as the pandas data frame, which is data of temperature. So this is how this plot has been created, and the base level of all these plots, like creating the x variables and like the x-axis, x limits, everything will be set by the library which is called as matplotlib. So there, like the basic figure will be created, and all those x-axis, y-axis will be created, and the input data will be plotted over, and that's how these plots have been generated. So you can see another example like pair plot. Pair plot will take every input and the output, and draws two things. One is for univariate histograms and bivariate plottings, like scatter plots. I think I have answered that.
Thank you for
And
your. Okay.
Yes. Another doubt is there, like, what is the significance of random state in train test split that I can see in the message. So the random state that has been provided as input there is to choose for whenever you're going to split the data, it won't take it in the order right from 0 to 100, for example. So the random state number will define how much randomly that those particular values will be chosen for the train and test split. So that can be like if that random state is very less, it doesn't matter with how data is being used, but it only matters when you have large number of data and the split needed to happen randomly so that it can the model can have more advantage over learning instead of having it in a very linear fashion that we have at like the data collected over time to time. So the random state defines that.
Thank you for your informative session, sir.
Thank you.
I request all the participants to join for the next session at 2 p.m. Thank you everyone for participating.
Thank you all. Thank you for your participation. Thank you.
Thank you, everyone.